everybody, today's lesson is about periodic trends. So one of the things that drives the periodic trends that we see, things like atomic radius or electronegativity, is the shielding effect. The shielding effect has to do with electrons that are closer to the nucleus, reducing the amount of attraction that those valence electrons, the furthest electrons, feel from the nucleus. So in general, we know that the larger energy levels are, or like the higher the energy level, the larger it is, right? And so the smaller energy levels are closer to the nucleus, the larger ones are further away. And so the electrons that are in those higher energy levels will spend most of their time further away from the nucleus than those electrons that are in the smaller energy levels. So what happens is we know that electrons are all negative, right? And we know that two negative charges repel each other. So those valence electrons in those larger energy orbitals are attracted to the nucleus because the nucleus is still positive and the electrons are still negative. But they also feel this repulsion from those electrons that are closer to the nucleus. So those electrons in the first energy level don't have that issue. They are just attracted to the nucleus, but they are repelling the electrons that are further away from the nucleus. We call that shielding. So the electrons in those outer energy levels are shielded from the nucleus by the electrons in the lower energy levels. And so in general, what that causes to happen is the overall attraction for those outer electrons from the nucleus is reduced. We call this the effective nuclear charge. The symbol for that is Z and then EFF for effective. So that's the actual charge experienced by the electron. And that's taking into account the fact that it's being shielded from those or through those other electrons. So Z is the actual nuclear charge, which comes from our atomic number, how many protons we have in the atom. And sigma here is the shielding constant, which you guys won't have to figure that out or anything. It's just, you should know that the effective nuclear charge is basically the actual nuclear charge, the number of protons, minus this constant that takes into account the fact that those inner electrons, those core electrons, are shielding the outer electrons from the nucleus. So this shielding effect drives a lot of the periodic trends that we see. The more energy levels we have, the more shielding will occur. So what you're going to be doing in class is looking into these different trends, things that we looked at last year, atomic radius, ionization energy, and you're going to kind of put together some information about each of these trends. There are slides here that will give you some information just as a reference, but you can also use your book, the internet, notes from last year, whatever works for you and your group. All right, so for the first part of the periodic trends activity, you guys are going to be assigned into groups within the slideshow. So there's slides that look like this, periodic trends, AP Chem. You guys are going to get together with your group. So as you scroll through the slides, you'll find your name signed on one of the slides with other group members. And on that first slide for your trend, there's going to be an assigned section in the book, an article that you can read on the internet, and then a video. So you guys should look through those things. And then each slide will tell you what like information is required. You can add pictures if you'd like. Just make sure you cite all your sources that you use. And you can do that directly on the slide by linking it or putting it in the like the comments at the bottom. And then there should be some examples, but you should work those out on your slides. So you're going to have about 30 minutes in class today to do this. So just, this is from a previous year, but you'll see something like this. You'll see your names over here, and then some readings or videos to look at. And then each slide will tell you what to do. So here you want a definition of the atomic radius and a picture that shows you what atomic radius means. On this slide, you want to describe the trend in a group, so the vertical columns on the periodic table. In this slide, you have to explain why that trend works that way. In this one, it's the periodic trend, so from left to right or right to left. Here again, you explain it. And then you do a couple of examples so that you can find examples in the book, on the homework, or just looking them up on the internet. And I just want you to kind of work through that on the slide. So you could take a video of yourself doing that or just write it out. And you can write it out on paper if that works better and take a picture of it. So you'll do 2 examples, and then any sources you can put here. Again, if you do pictures and you want to just link them on the slides, that's fine too. But yeah, you'll find all the different trends. They should all look pretty much the same as this. And once you are finished with that, you'll look at this second part of the activity. You'll be assigned to new groups here. And in this part, you're going to be looking at all of the trends. So in the first part, you're just focusing on one trend per group. In this part, each new group will have someone who focused on one of the trends. So you guys will be able to work together. And you're going to try to create some sort of resource for a baby chem student who is struggling to understand periodic trends. So you can use the slides and the information that you gathered while you were making your slides to help you. You can look at my slides on Canvas, but you need to kind of like explain it in a way that you think would help someone who's in baby chem to understand periodic trends and how they work. So just make sure you remember that it's for a baby chem student. So there's some options you can use. You can create a video, you can create a picture book, or you can create a Google website. So choose one of those in your group, and then you can go ahead and get to work on it, and let the sub know if you have any questions.